A queue, you go to book a movie ticket, you stand in a queue, right? With a lot of people, you stand in a queue, the one in front of you buys the ticket, and then you get a chance to buy the ticket, and then you buy the ticket, and the one behind you buys the ticket. So you go to a railway reservation counter or an aeroplane reservation counter, you go there, you stand in a queue. And what is the principle used here? Does the queue follow the last in first out principle? Is it that the last person who enters the queue gets the chance to buys the ticket first? Then it would have been a last in first out principle, right? But that's not typically a queue. Maybe there are a few exceptions sometimes, but it's called as jumping the queue. In a queue, the person who enters the queue first gets the chance to buy the ticket first, right? So the principle a queue follows is it follows a first in first out principle, or just recollect what is a stack. A stack was last in first out LIFO principle, and a queue has a first in first out principle. You have seen enough queues in real life, and so no need of any more examples of queues. What are the functions of a queue ADT? Okay, one is Enqueue. Enqueue is it's similar to push into a stack, but it's going to we call it Enqueue. For queue, enter queue. You're going to enter the queue, right? So let me have a queue here as a picture of a queue. Okay, and I have a queue of numbers, and this is the a queue as a front and a back, as you know, right? Now, when you enter a queue, let's say you want to enter Enqueue 100. If you Enqueue 100, what will happen? It's going to go to the back of the queue. Now, next function is DQ. It corresponds to pop in a stack, and in a DQ, which element is DQ'd first? The element which is in the front of the queue. So 10 goes out of the queue. So now the front is 20, right? Now another function is front of the queue. This is similar to top of the stack, and front of the queue is 20 here. And finally, we also have this empty to check whether the queue is empty or not. Now it's clear. I think no need to go through an examples of queue. Let's quickly go through. So what happens if I apply DQ, 20 is removed right now, right? And now let's say I Enqueue 95, 95 comes here. Okay, I DQ next, 15 goes out. Okay, right now the front is actually changed to 100 right now. So this is how a queue is going to work. I want to implement the queue ADT. What is it I'm going to use? I am going to use a linked list here. Just like we use a stack, I'm going to use a linked list. And let me have a linked list as an example. I'm going to use a singly linked queue being represented as a linked list. And now the head of the linked list corresponds to the front of the queue. Okay, so 25 is the front of the queue. So now let me say I want to implement DQ operation. That is, I want to remove the front of the queue. What is it I need to do? So the DQ operation. So so this is very easy. We know how to remove the head node, right? We just have to remove 25 and just we just remove the head node 25 and point head, the head points now to the second node, which had the number 15. That's easy to do. And to implement this, you had to see only one node. You had to traverse through only one node to get um, to implement the DQ function. Now, what about the function Enqueue? Let's say I want to enqueue 25. That is, I want to add 25 to the back of the queue, or in this case, the tail of the queue of this linked list. Okay, so in this case, we'll have to add here, right? This is going to be tricky because for to implement this, we'll have to traverse the entire linked list and add this number 25 to the tail of the queue. I mean, this takes a lot of time, as we have seen. This is not a good implementation. Okay? So we want a better implementation. And what is a better way to implement? We use a singly linked list with tail. That this can implement the enqueue operation. Now, if you want to do the enqueue operation, it's clear, very easy to do. You put 25 here, you have the tail pointer, use the tail pointer to get the node with 35 and do this, remove this null from here and add null here. This is very easy to do. This is something we saw earlier. So this is so with a singly linked list with tail, we can implement a queue.